In everyday use and in kinematics, the speed of an object is the magnitude of its velocity, the rate of change of its position. It is thus a scalar quantity. The average speed of an object in an interval of time is the distance traveled by the object divided by the duration of the interval. The instantaneous speed is the limit of the average speed, as the duration of the time interval approaches zero. Like velocity, speed has the dimensions of a length divided by a time. The unit of speed is the meter per second, but the most usual unit of speed in everyday usage is the kilometer per hour, or, in the US and the UK, miles per hour. For air and marine travel, the knot is commonly used. The fastest possible speed at which energy or information can travel, according to special relativity, is the speed of light. In a vacuum, CE equals 299,792,458 meters per second, approximately 1,079,000,000 kilometers/h, or 671 million mph. Matter cannot quite reach the speed of light, as this would require an infinite amount of energy. In relativity physics, the concept of rapidity replaces the classical idea of speed. Definition: the Italian physicist Galileo Galilei is credited with being the first to measure speed by considering the distance covered and the time it takes. Galileo defined speed as the distance covered per unit of time. In equation form, this is where v is speed, d is distance, and t is time. A cyclist who covers 30 meters in a time of 2 seconds, for example, has a speed of 15 meters per second. Objects in motion often have variations in speed. A car might travel along a street at 50 km/h, slow to 0 km/h, and then reach 30 km/h. In mathematical terms, the speed v is defined as the magnitude of the velocity v, that is, the derivative of the position r with respect to time. If s is the length of the path traveled until time t, the speed equals the time derivative of s. In the special case where the velocity is constant, that is, constant speed, in a straight line, this can be simplified to v equals s/t. The average speed over a finite time interval is the total distance traveled divided by the time duration. Instantaneous speed. By looking at the speedometer, one can read the speed of a car at any instant, or its instantaneous speed. A car traveling at 50 km/h generally goes for less than 1 hour at a constant speed, but if it did go at that speed for a full hour, it would travel 50 kilometers. If the vehicle continued at that speed for half an hour, it would cover half that distance, 25 kilometers. If it continued for only 1 minute, it would cover about 833 m. Average speed. Different from instantaneous speed, average speed is defined as the total distance covered over the time interval. For example, if a distance of 80 kilometers is driven in 1 hour, the average speed is 80 kilometers per hour. Likewise, if 320 kilometers are traveled in 4 hours, the average speed is also 80 kilometers per hour. When a distance in kilometers, km, is divided by a time in hours, h, the result is in kilometers per hour, km/h. Average speed does not describe the speed variations that may have taken place during shorter time intervals, as it is the entire distance covered divided by the total time of travel, and so average speed is often quite different from a value of instantaneous speed. If the average speed and the time of travel are known, the distance traveled can be calculated by rearranging the definition to. Using this equation for an average speed of 80 km per hour on a 4-hour trip, the distance covered is found to be 320 kilometers. Expressed in graphical language, the slope of a tangent line at any point of a distance time graph is the instantaneous speed at this point, while the slope of a chord line of the same graph is the average speed during the time interval covered by the chord. Tangential speed. Linear speed is the distance traveled per unit of time, while tangential speed, or tangential velocity, is the linear speed of something moving along a circular path. A point on the outside edge of a merry-go-round or turntable travels a greater distance in one complete rotation than a point nearer the center. Traveling a greater distance in the same time means a greater speed, and so linear speed is greater on the outer edge of a rotating object than it is closer to the axis. This speed along a circular path is known as tangential speed, because the direction of motion is tangent to the circumference of the circle. For circular motion, the terms linear speed and tangential speed are used interchangeably, and both use units of m/s, km/h, and others. Rotational speed, or angular speed, involves the number of revolutions per unit of time. All parts of a rigid merry-go-round or turntable turn about the axis of rotation in the same amount of time. Thus, all parts share the same rate of rotation, or the same number of rotations or revolutions per unit of time. It is common to express rotational rates in revolutions per minute, RPM, or in terms of the number of radians turned in a unit of time. There are a little more than 6 radians in a full rotation, 2 radians exactly. When a direction is assigned to rotational speed, it is known as rotational velocity, or angular velocity. Rotational velocity is a vector whose magnitude is the rotational speed. Tangential speed and rotational speed are related. The greater the RPMs, the larger the speed in meters per second. Tangential speed is directly proportional to rotational speed at any fixed distance from the axis of rotation. However, tangential speed, unlike rotational speed, depends on radial distance, the distance from the axis. For a platform rotating with a fixed rotational speed, the tangential speed in the center is 0. Towards the edge of the platform, the tangential speed increases proportional to the distance from the axis. In equation form, where v is tangential speed and Greek letter omega is rotational speed. One moves faster if the rate of rotation increases, a larger value for, and one also moves faster if movement farther from the axis occurs, a larger value for r. Move twice as far from the rotational axis at the center, and you move twice as fast. Move out 3 times as far, and you have 3 times as much tangential speed. In any kind of rotating system, tangential speed depends on how far you are from the axis of rotation. When proper units are used for tangential speed, v, rotational speed, and radial distance are the direct proportion of v to both r, and becomes the exact equation. Thus, tangential speed will be directly proportional to r when all parts of a system simultaneously have the same, as for a wheel, disc, or rigid wand. The direct proportionality of v to r is not valid for planets, because planets have different rotational speeds. Units. Units of speed include meters per second, symbol ms1, or m/s, the she-derived unit. Kilometers per hour, symbol km/h. Miles per hour, symbol mi/h/rmph. Knots, nautical miles per hour, symbol kn, or kt. Feet per second, symbol fps, or ft/s. Mach number, dimensionless, speed divided by the speed of sound. In natural units, dimensionless, speed divided by the speed of light in vacuum, symbol CE equals 299,792,458 m/s. Conversions between common units of speed m/s km/h mph not ft/s1 m/s equals 13.62.2369361.943844 km/h equals 0.277777810 0.6 to 1371 0.5399570 0.9113 441 mph equals 0.4470 for 1.60934410 0.8689761 1.466667 not equals 0.514444 1.8521 1.15077911 1.6878101 foot/s equals 0.3048 1.097280 6818180.5924841. Values in boldface are exact. Examples of different speeds. The section needs additional citations for verification. Please help improve this article by adding citations to reliable sources. Unsourced material may be challenged and removed. May 2013. This section may contain excessive, poor, or irrelevant examples. Please improve the article by adding more descriptive text and removing less pertinent examples. See Wikipedia's Guide to Writing Better Articles for further suggestions. May 2014. Orders of magnitude: speed m/sft/skm/hmph. Notes: approximate rate of continental drift 0.00000001, 0.00000003, 0.00000004, 0.00000024 centimeters/year. Varies depending on location. Speed of a common snail: 0.001, 0.003, 0.004, 0.0021 mm per second. A brisk walk: 1.75.56.13.8. A typical road cyclist: 4.4, 14.4, 16, 10. Varies widely by person, terrain, bicycle, effort, weather. A fast martial arts kick: 7.7, 25.2, 27.7, 17.2. Fastest kick recorded at 130 milliseconds from floor to target at 1 meter distance. Average velocity: speed across kick duration. Sprint runners: 12.2, 40, 43.92, 27. Usain Bolt's 100-meter record. Approximate average speed of road cyclists: 12.5, 41.0, 45, 28. On flat terrain will vary. Typical suburban speed limit in most of the world: 13.8, 45.3, 50, 30. Taipei 101 Observatory elevator: 16.7, 54.8, 60.6, 37.6, 1010 m/min. Typical rural speed limit: 24.6, 80.66, 88.5, 56. British national speed limit, single carriageway: 26.8, 88, 96.56, 60. Category 1 Hurricane: 33, 108, 119, 74. Minimum sustained speed over 1 minute speed limit on a French autoroute: 36.1, 118, 130, 81. Highest recorded human-powered speed: 37.02, 121.5, 133.2, 82.8. Sam Whittingham, in a recumbent bicycle. Muzzle velocity of a paintball marker: 9295, 320, 200. Cruising speed of a Boeing 747-8 passenger jet: 255, 836, 917, 570. Mach 0.85 at 35,000 feet, 10,668 m. Altitude. The official land speed record: 341.1, 1119.1, 1227.98, 763. The speed of sound in dry air at sea level pressure, and 20 C: 343, 1125, 1235, 768. Mach 1 by definition. 20 CE equals 293.15 kelvins. Muzzle velocity of an AK-47 assault rifle bullet: 710, 20, 330, 2600, 1600. Official flight airspeed record for jet-engined aircraft: 980, 30, 215, 30, 530, 20, 194. Lockheed SR-71 Blackbird space shuttle on re-entry: 7,800, 25,600, 28,000, 17,500. Escape velocity on Earth: 11,200, 36,700, 40,000, 25,000, 11.2 kilometers. S1 Voyager 1 relative velocity to the Sun in 2013: 17,000, 55,800, 61,238,000. Fastest heliocentric recession speed of any human-made object: 11 miles/s. Average orbital speed of planet Earth: 29,783, 97,713, 107,218, 66,623. Speed of light in vacuum, symbol C, 299,792,458 983,571,056 1,079,252,848 670,616,629 exactly 299,792,458 hem/s by definition of the meter. Vehicles often have a speedometer to measure the speed they are moving.